Okay guys, we're in the last installment of lesson 5. We're going to be finishing up the last few problems and vocabulary. So here we're asked for the measure of two complementary angles. Okay, complementary means that these two have to equal 90 degrees. We know that one angle is 6 degrees less than 5 times the measure of the other. Okay, so we have an angle 1 and we have an angle 2, just like we had before. Now, angle 1 plus angle 2 will need to measure a total of 90 degrees. We have that given that the angles are complementary. So they have to add up to the 90 degrees. Okay? We're going to say that angle 1 is simply x. It's a particular measure, and we know that angle 2 is 6 degrees less than 5 times the measure. So 5 times the measure, subtract 6, and that whole thing needs to equal 90. So now we can solve for x. Okay? X plus 5x, I have 6x, 90, and I add 6 here to both sides to get 96. Okay, we have 13 degrees. 6 into 96 is 13. Did we have that right? No, I think my math's a little faulty here, sorry. Okay, 6 into 9 goes 1 time. I'm left with 3, 36, 16. Much, much better. Okay? So I know that my x is this, but what does this mean for angle 1 and angle 2? We need to find the measures of both of those. Okay, I know that angle 1 was simply x, so that's 16 degrees. But what about angle 2? Well, angle 2 was 5x minus 6 degrees of that. We know that our x is really 16 degrees. 5 times 16, we have 80 minus 6 is 74. Now we need to check. Okay, 16 plus 74, do they equal 90? Yes. Another way that I could have done this, instead of plugging it into here, is I could have said, well, if this angle 1 is 16 degrees, I know that my other angle has to be 90, subtract the 16. Okay, so does any of this match? I see 14, I see 16, right here, 16 and 74, okay? This is best always in this case. If you don't have those angles given to you, start working it out, then find the answer, as compared to the one that we had earlier, where I could start with the answers and see how they fit on my diagram. So there's our answer. Okay, let's get rid of all this. Perpendicular lines. Perpendicular lines are those where we have things meeting at a 90-degree angle. And whenever you see this 90-degree angle, you're going to see this little box in the corner right there. Perpendicular lines will intersect so that they actually form 4 right angles. Each of those 4 angles will be right angles. Okay, they're going to be congruent, meaning that they're the same size, the same measure. The segments and the rays can be perpendicular to lines or other line segments and rays. And it says the right angle symbol, which is this right here in the corner, indicates that the lines are perpendicular. Okay? We can also read it here using this symbol, saying, hey, line AD, okay, remember this is the symbol for a line, is perpendicular to, you're showing it like a wall is meeting a floor, okay, or we're standing a book on end. AD is perpendicular to CB in this case. So let's make use of that. It says find X and Y so that KO and HM are perpendicular. Okay, so we have HM right here. We have KO right through here. And it says we need to find a particular value of X and a particular value of Y, so these two are going to be perpendicular. Well, what that means is this here needs to equal exactly 90 degrees. Okay? This here, from here to here, is also going to equal 90 degrees. We're given some information about KJI and about IJH. Okay? And we are given information about MJO. Okay, well, let's start with that MJO. Okay, all we have is one angle. And we know that that particular angle, MJO, is a right angle. Because we know that we're looking for it to be perpendicular. Okay? Angle MJO is equal to 90 degrees. Well, MJO is also equal to 3y plus 6. Okay, now we can solve for y. 3y is equal to, subtract 6 from both sides, we're left with 84. So y is 28. Okay, 3 times 20 is 60. 3 times 8 is 24. 60 plus 24 is 84. So y is now 28. Okay, that helps us figure out what y was. We've got that. How do we find x? Well, both of these angles, KJI and IJH, together we're supposed to make 90 degrees as well. So KJI plus angle IJH are also equal to 90. We know that KJI is also 3x plus 6, and that IJH is 9x. So now we can simply solve for x. Okay? 3x plus 9x, we have a total of 12x on this side. We'll bring the 6 over to this, minus 6. We're back with that 84 number again. 12 goes into 84 7 times. So we have for our final answer that y equals 7 and x equals, sorry, got that backwards. X equals 7 and y equals 28. Those are the values that are needed so that KO and HM are perpendicular. And so when they walk us through, they tell us the same thing. Okay? Sum of the parts equals the whole. We know that they have to equal 90 degrees. So we're going to substitute in, combine like terms, and solve. And so we get x equaling 7 and y equaling 28. So now we have a new figure. Find x so that AD and CE are perpendicular. Here's our AD. Here's our CE. We want to know for sure that this is perpendicular. And we have two lines, so all four are going to be perpendicular. Except for the fact that we have this FB cutting AC into parts, or AFC, sorry. So find x so that AD and CE are perpendicular, meaning that these angles have to be 90. Okay, the only information that we're given is here in angle AFC, we have two separate angles, one equaling 4x and one equaling 5x. Those two angles, as we add them together, have to equal 90. Angle AFB plus angle BFC must equal 90 degrees together. What do we know about AFB? Well, that's equal to 4x. BFC, well, that equals 5x. Together, they'll equal 90. 9x equals 90, x equals 10 degrees. Okay, so you'll find that the answer is 10. Okay, now it's important to know what can you assume when you have a particular diagram. It can be assumed that all points in this particular diagram are coplanar. They're all lying along the same plane. It can also be assumed that G, H, and J, that all of these three are collinear. We know that these four rays, HM, HL, HK, G, J, all intersect at H. We know that H is between G and J, that L is interior of the angle MHK. Okay? All of this can be assumed. But we don't know for certain unless we are told that HM is perpendicular to HL. We really don't know what this angle is right now. Okay, we cannot assume that JHK is congruent to GHM. We don't know their sizes. Okay? So unless you are specifically told that angles are congruent, that segments are congruent, or something is perpendicular, either by the wording of the question or by the symbols that are shown, remember that for a line to be congruent with another line, they need to have these same slashes across. When it's angles, for it to be congruent, you're going to see this little measure sign. And how many there are for that tell you how many, whether it's congruent with another section or not.